As you can imagine, the only criteria to be tested with a speed test is the speed of your particle. Of course, as with many of the tests, quite some flexibility is added with various ways of measuring that speed, or acceleration. Let's have a look at the options. Up here, actually if you have a look at this flow first, we'll just run through what it does. We birth particles between frame 0 to 13, and we can see we birth only 16, subframe sampling is on. We position the particles on this icon here. We set a speed of 160, some divergence to give them some random direction. We apply gravity to them to make them fall down, and we apply force of drag to actually slow them down as well. Then we have two different tests set up here for speed, and this is just to show you basically two different setups. We have speed test based on speed Z, and you can see I'm using a negative value in this one. And in this test, which is actually turned off at the moment, I'm using a positive value and I'm testing to see if the particle speed drops below that. Again, I'm using velocity Z. I'm using velocity Z because the particles are being fired upwards on the Z axis, and I want to test whether they're traveling upwards at a certain speed or if they're traveling downwards at a certain speed. And both of these setups work on that principle. As the particle's flying up into the air, you can see it's spawning by travel. So this is actually very similar to the previous chapter where we actually showed you the kind of firework effect. And you can see those particles are being sent out. There's a force of wind being applied to them to give them some random breakup, and they're being deleted after a range of 40 plus minus 30, so from 10 to 70. So if I play this through, just quickly scrub, you can see there go our particles flying up into the air. So before we continue, let's actually have a look at the options that we have in the test here. So we have a choice of these options. We have velocity magnitude, and this is the default method, and it simply measures the particle velocity in system units over a period of 1 second. This would be what most people would call the actual speed of the particle. The next options that we have are the velocity X, Y and Z, and these options are exactly the same as velocity magnitude, except now they're actually measured only in one axis, either in X, Y or Z. Then we have acceleration magnitude, and this option is useful for when you need to test if your particles are actually accelerating beyond a certain threshold. This can be caused by a number of factors, the most common of which would be a force operator such as gravity or wind, or maybe a fine target test. Then below this option you can see you have the same option again, but again limited to the X-axis, Y-axis or Z-axis. Then we have steering rate, and the steering rate can simply be thought of as how much the particle is changing its course over time. With no steering rate, the particle would be travelling in a straight line. With a steering rate of 360, the particle would be travelling in a circle. So you can use this option to detect when your particle is changing direction beyond a certain threshold, and then obviously pass the particle on to a new event. The next option is test true when accelerates, and quite simply the criteria here is this test will test true the moment the particle accelerates in any way. The next option obviously works in the opposite way. This will only test true when the particle decelerates in any way, but that's in any way whatsoever. So below these you have these parameters, which you can see here, and you can see you have is less than test value, and you have the option of using that, or is greater than test value. So you can obviously choose whether you want to test if the speed is above a certain value or below a certain value, or if the velocity is a certain value or below a certain value. Now if we go down to true when true when decelerates and true when accelerates, you can see that none of these options are available because these are an absolute test. This is just testing for any acceleration, and this is testing for any deceleration. So whenever either of those particular criteria become true, the test is true and the particle gets sent on to the next event. As you can see, if you look at the other options, velocity magnitude, you can test for above and below, and steering rate, again, you can test as well. All of the other options, you have these further options here. Then you have the test value, and that is obviously quite simply the value that you're testing for, whatever that may be. For instance, with steering rate, if you're using a test value of 128, it's going to look at the particle, and if it finds a test value which is less than that in this particular example, then it'll actually use that value and